Okay, so how do you do a floating point binary? There are three types of questions. If you look at the link below video, there's an article on this, which is this, and if you read through all these notes and look at all the examples, it leads up to these practice 1, 2, and 3, and then some past paper questions from 2019, 2020, and 2021. So the first point is practice 1, and in this one you need to convert these normalized numbers. So these binary numbers are normalized. How do we know? Because there's either a 1 or a 0 or 0 or 1. If it was a 0 or 0 or a 1 or 1 as the most significant bits, then it would not be normalized, but these are normalized. Convert them to denary. 3-bit exponent, 5-bit mantissa. So practice 1, question 1 is 0, 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, and then that's the exponent. The exponent is 3. Now we're going to imagine there's an imaginary decimal point here. It's a positive number, so we need to move it to the right. 1, 2, 3. So this is what this number is multiplied out by 3. What is this number? This number is, well, we've got a 1 in the 1 to 4 column and a 1 in the half column, so 4.5. Now you have to do the rest of these practice questions, 2, 3, and 5. 3 and 4 are actually the same question. It's a slight mistake. I might update that. Practice 2. This is another type of question that you could get asked in the exam. What have we got to do here? We need to normalize the following numbers. So these are not normalized because they've got 2 zeros at the front or 2 ones, as in here. There are 8 bits for the mantissa, 4 bits for the exponent. So let's look at question 1. 8 bits for the mantissa, that's the mantissa, and 4 bits for the exponent. So how are we going to normalize this? Well, we need to move the decimal point either left or right, so it's between a leading 1 and a 0, 0 and a 1. Now this is a positive binary number, so we're going to need to move this decimal point. We wouldn't move it here because then it would become a negative number, so we want to move it here. And we don't want 2 zeros at the beginning. We'll add another 0 on the end to keep it at 8 bits. So we have now moved this decimal point 1 to the right. Now we would need to move it 1 to the left, or -1 back to get it into its original form, and so we take -1 off this exponent. This exponent is, well, there's a 1 in the 1 and a 1 in the 4. It's 5. So if we take 1 off this exponent becomes that, which is 4. Sorry. And this is what this number is what this number would be if it was normalized. So we shift that decimal point and then we add or subtract from the exponent. So now go and do questions 2, 3, 4, and 5. Practice 3. This is probably the hardest one, the one that's most likely to come up in the exam. If you look at the past paper questions down below, like F here, that's exactly what they're doing. They're saying, show the denary number minus 5.25 in floating point binary form, representing the mantissa and the exponent in 2's complement, using as few bits as possible. Right. So we're going to do minus 9.25, so question 1. So what is minus 9.25 in floating point binary with 8 bits for mantissa and 4 bits for exponent? Firstly, we need to work out what 9.25 is. So 9.25 is, well, it's always in 2's complement, so we're going to have a 0. So what is 9.25? 9.25. What does this equal? We're going to have a 0 here, and then we're going to have a 1 in the 8 column, and then a 0 in the 4, a 0 in the 2, and a 1 in the 1 column. And then 0.25 is, well, a 0 in the half and a 1 in the quarter, or the 0.25 column. So this is 9.25. Now we're going to need to 2's complement this. How do we 2's complement it? We need to flip all the bits. 1, 0, 1, 1, 0. 1, 0, and then we're going to add 1. So this would become 1, 0, 1, 1, 0, 0.11. Now we can double check that this is minus 9.25. So now we've got a minus 16 plus 4 plus 2 plus 0.5, 0.25, which is 0.5, which is 0.75, 0.5 plus 0.25, which is 0.75, and that equals minus 9.25. You can get a calculator out and check that. So now this is not normalised, so we're going to need to normalise this. We're going to need to shove this point in right up to the end here. So we're going to need to move it 1, 2, 3, 4 places to the left. 4 places. Let's copy that again. We need to shove that 4 places to the left. So 1, 2, 3, 4 here. So it's between the leading 1 and 0. This is a negative number. It's in 2's complement. So we're going to need to always keep a 1 in that column there, in the minus 16 column. How many bits are there? 1, 2, 3, 4, 5, 6, 7. Let's keep it at 8 bits. So we'll pad it with an extra 0 on the end. And what's the exponent? Well, we're going to need to move it back 1, 2, 3, 4 places. So it's going to be 4, positive 4. So the positive 4 in binary is 0, 1, 0, 0. So 1, 2, 4. So that's the exponent, and this is the mantissa, and that is what minus 9.25 is in positive binary. So now have a go at these other ones, like minus 5.25. I'll do one more because these are a bit tricky, but you can pause the video and have a go at the rest if you don't need to watch me. But minus 5.25, what is that in positive? What's that in positive? Here's the method. What's it in positive? What is the 2's comp of the positive? And then move the point to leading 1 or 0. Yeah. So 5.25. What is that in positive? Well, we need a 0 to lead with because it's positive. Then we're going to need a 1 in the 4 column and then a 1 in the 1 column. So that's 5.25, a 0 in the half, a 1 in the 0.25. And then it's 8 bits, so we need to keep 8 bits, and that's 6, so we'll pad it with 2 bits. Let's 2's complement this now. So we're going to flip all the bits. 1, 0, 1, 0, 0.1011. I'm going to add 1 to this. So it's going to be a 1 carry the 1. So 1, 0, 1, 0, 0.1. And then it's like 1 carry is 0, carry the 1, 0, carry the 1. And then 1. So we've got that. This is minus 5.25. Let's double check that. It's 8 plus 2, which is 6, plus, sorry, minus 8, because it's a most significant bit is that it's in 2's complement, so that is an 8, but it's a minus 8, plus 2, plus 0.5, plus 0.25, and that will be minus 5.25, because 8 minus 2, 8 minus 8, minus 8 plus 2, 6, plus 0.75 is minus 5.25. So we now need to put this in normalised form. So we're going to need to move the point all the way over to here, making sure we've always got a leading 1. So we're going to go 1, 2, 3. So we're going to need, we moved it 3 to the left, so we're going to need to move it positive 3 to the right. So the exponent is going to be 3. And 3 in binary is 1 plus 2, which is 3. So that is how we represent minus 5.25 in normalized floating point binary, a normalized floating point binary using an 8-bit mantissa and a 4-bit exponent. So I'll put these examples in the link below in this article, but go and have a read through that and go through the other practice questions and the past questions, and you should be able to understand how to do any of